Welcome back. We've talked about nonlinearities for some time now, without elaborating in more detail, and that's a topic we would like to address in this lesson. In a machine learning context, nonlinearities are also called activation functions. Henceforth, that's how we will refer to them. Activation functions transform inputs into outputs of a different kind. Think about the temperature outside. Assume you wake up and the sun is shining, so you put on some light clothes. You go out and feel warm and comfortable. You carry your jacket in your hands. In the afternoon, the temperature starts decreasing. Initially, you don't feel a difference. At some point though, your brain says, it's getting cold. You listen to your brain and put on your jacket. The input you got was the change in the temperature. The activation function transformed this input into an action. Put on the jacket or continue carrying it. This is also the output after the transformation. It is a binary variable, jacket or no jacket. That's the basic logic behind nonlinearities. The change in the temperature was following a linear model as it was steadily decreasing. The activation function transformed this relationship into an output linked to the temperature but was of a different kind. Okay, in machine learning, we have different activation functions, but there are a few used much more frequently than others. Here is a table with 4 of the most commonly used activation functions. Let's go through one row to see how the table is organized. First, we have the sigmoid, also known as the logistic function. Here is its formula. Next to it, we have its derivative. As you may recall, the derivative is an essential part of the gradient descent. Naturally, when we work with TensorFlow, we won't need to calculate the derivative, as TensorFlow does that automatically. Anyhow, the purpose of this lesson is understanding these functions, their graphs and ranges, in a way that would allow us to acquire intuition about the way they behave. Here's the function's graph. And finally, we have its range. Once we have applied the sigmoid as an activator, all the outputs will be contained in the range from 0 to 1. So, the output is somewhat standardized. Alright, here are the other 3 common activators. The tanh, also known as the hyperbolic tangent. The ReLU, aka the rectified linear unit, and the softmax activator. You can see their formulas, derivatives, graphs, and ranges. The softmax graph is not missing. The reason we don't have it here is that it is different every time. Pause this video for a while and examine the table in more detail. You can also find this table in the course notes. So, all these functions are activators, right? What makes them similar? Well, let's look at their graphs. All are monotonic, continuous, and differentiable. These are important properties needed for the optimization process. As we are not there yet, we will leave this issue for later. Before we conclude, I would like to make this remark. Activation functions are also called transfer functions because of their transformation properties. The two terms are used interchangeably in machine learning context, but have differences in other fields. Therefore, to avoid confusion, we will stick to the term activation functions. Alright, let's wrap it up here. Thanks for watching.